Hello my dear students, I am Dr. Jithender Reddy, working as Senior Assistant Professor in the Department of Mathematics and Management Sciences, VJEC JYOTHI Institute of Engineering and Technology. In this video, we are going to learn Bernoulli's differential equation. It is one of the non-linear differential equation. We can convert this non-linear differential equations to the linear differential equation. In the last video, we learned linear differential equations of first order. If you know that, then you can able to understand this Bernoulli's differential equation. It is a one of the non-linear differential equation. We can convert to the linear differential equation. Then we can solve the differential equations very easily. First, we have to recall the linear differential equations. In the last video, we learn linear differential equation in y and a linear differential equation in x. This is a linear differential equation in y. Here y power 1 and its derivative power 1. So that we can say it is a linear differential equation in y. And its integrative factor is e to the power integral p of x into dx, and its general solution is y into integrative factor is equal to integral the right hand side of the function q of x into integrative factor into dx plus c. Coming to the linear differential equation in x, here x power 1 and its derivative power is a 1, x power 1, its derivative power is a 1, so that we can say it is a linear differential equation in x, and these are not multiplying together. That's why we can say it is a linear differential equation in x, and its integrative factor is e to the power integral p of y into dy. Coming to the its general solution, x into integrative factor integral the right hand side of the function into integrative factor dy plus c. If you know these principle, then we can able to solve the Bernoulli's differential equation. Here I wrote two types of Bernoulli's differential equations. One is Bernoulli's differential equation in y. Another one is the Bernoulli's differential equation in x. dy by dx plus p of x into y is equal to q of x into the y to the power n. We know the linear differential equation in y. We know here up to this one linear differential equation. It does not contain the y to the power n on the right hand side. Then we can say it is a linear differential equation in y. Just the right hand side function q of x multiplied with y to the power n, then we can say that is a Bernoulli's differential equation in y. Similarly, coming to here in the Bernoulli's differential equation in x, up to this one, we can say it is a linear differential equation in x. Here x power 1, its derivative power 1 does not multiply together, so that we can say it is a linear differential equation in x. It does not multiply the x to the power n on both. X does not multiply x to the power n on the right hand side. We can able to solve these differential equations for n is equal to 0. Case 1, n is equal to 0, n is equal to 1, n is equal to 2. If n is equal to 0, then it becomes a linear differential equation, that is a look like dy by dx plus p of x into y is equal to q of x. Y power 0, that is a 1, so that we can say it is a linear differential equation in y. We can solve it according to the linear differential equation. Similarly, here also n is equal to 0, then it will become a linear differential equation in x. Coming to the second case, n is equal to 1, then we can write this differential equation as dy by dx plus p of x into y is equal to q of x into y. This p of x into y we can write on the right hand side. minus p of x into y plus q of x into y. Then dy by dx is equal to, here y is a common, so that q of x, then I am writing the minus p of x whole into y. Then we can solve this differential equation according to the variable separable method. Dy by y, this y I wrote on the left hand side, then this dx I am writing on the right hand side. P of x, sorry, q of x minus p of x whole into dx. Then write the integration on both sides, then we can get the required solution to the given differential equation. Coming to the third case, n not equal to 1, n not equal to 1, that means n is equal to 2, 3, 4 and so on. Case 3, n not equal to 1. We have to divide the y to the power n on both sides. It will become a linear differential equation when it does not contain the y to the power n, so that we have to divide the y to the power n on both sides. If you are writing the divided by y to the power n on both sides, then we can get 1 by y power n into dy by dx plus p of x into y divided by y power n, that can be written as 1 divided by y power n minus 1 is equal to q of x. We can convert this differential equation to the linear differential equation by substituting 1 by y power n minus 1 is equal to u. Write the differentiation to this, then we get some quantity to this one, that is this u is equal to y to the power 1 minus n. Write the derivative on both sides, then we can get the 1 divided by 1 minus n into du by dx is equal to 1 by y power n into dy by dx. We have to substitute these both quantities in this expression, then we can get 1 divided by 1 minus n into du by dx plus p of x into u is equal to q of x. Coming to the linear differential equations, the derivative coefficient is always a unity, so that we have to multiply the 1 minus n on both sides. If you are multiplying the 1 minus n on both sides, then it will be get the linear differential equation in u, so that we have to multiply the 1 minus n on both sides, then we can get the du by dx plus 1 minus n into p of x, then 1 minus n into q of x. This, it is a linear differential equation. It is a linear differential equation in u. Similarly, we can convert this differential equation to the linear when n not equal to 1. First, we have to divide the x to the power n on both sides, then we can get this. We have to substitute 1 divided by x power n minus 1 is equal to u, then we can get some quantity to this one. Put u is equal to 1 divided by x power n minus 1, that can be written as x power 1 minus n. Then coming to its derivative, du by dx is equal to 1 minus n into x power 1 minus n is a minus n into dx by dy. Then this can be written as, 1 minus n we are writing on the left hand side, 1 divided by 1 minus n into du by dy is equal to x power minus n, we can write the 1 by x to the power n into dx by dy. We have to substitute these both quantities in this expression, then we can get this one. Then multiply the 1 minus n on both sides, then we can get this one. It is a linear differential equation in u. Now, coming to the example 1, here y power 1 dy by dx whole to the power 1, and right hand side it does not contain the y square, then we can say it is a linear differential equation y. But right hand side it multiplied the y square, so that we can say it is a Bernoulli's differential equation. We are giving the equation number 1 to this. Now we have to convert this differential equation to the linear, so that we have to divide the y square on both sides. Y square on both sides, we get 1 by y square into dy by dx plus 1 by x into y divided by y square. Then we can get 1 by x into 1 by y is equal right hand side y square cancel. Then we can get x into sine x on the right hand side. Now we have to substitute 1 by y is equal to one variable u. Then we can get this quantity is equal to another derivative. For this expression we are giving the equation number 2. Now we have to substitute u is equal to 1 by y. We have to write the derivative for this one with respect to x. Then du by dx is equal to derivative of 1 by y is minus 1 by y square into dy by dy by dx. Then that implies 1 divided by y square into dy by dx is equal to minus du by dx. Now we have to substitute these both quantities in the equation number 2. We get 1 by y square into dy by dx is minus du by dx plus 1 by x into 1 by y is u is equal to x times of the sine x. But coming to the linear differential equations, the derivative coefficient is always unity, so that we have to multiply the negative to this. Then we can get du by dx minus 1 by x into u is equal to minus x times of the sine x. Now we are giving the equation number 3 to this. Here u power 1 and its derivative power 1, and right hand side we have the only one function in terms of the x, so that we can say it is a linear differential equation. It is a linear differential equation in u, so that here p of x is u coefficient, that is minus 1 by x, and the right hand side function q of x is minus x times of the sine x. Now we have to find its integrative factor, since the integrative factor is equal to e to the power integral p of x into dx, so that this is equal to e to the power integral minus 1 by x into dx. Then this is equal to e to the power integration of 1 by x is a log x. There we have the minus, so that we can write the minus log x, so that e to the power minus log x is we can write the e to the power log x to the power minus 1. M into log a is log a to the power m. According to this principle, I wrote the minus log x as log x to the power minus 1. And e and the log will be cancelled. Then we can write the x to the power minus 1. X to the power minus 1 means that is a 1 by x. Therefore, its integrative factor is 1 by x. Now, we have to write the general solution to the equation 3. the general solution of the linear differential equation 3 is, there u is a dependent variable, so that u into integrative factor is equal to integral the right hand side of the function q of x into integrative factor into dx plus c. Then that implies, since what is the u here, u is 1 by y and integrative factor is a 1 by x, and the right hand side function is q of x is equal to minus x into sine x. We have to substitute these three quantities in the general solution formula. U is equal to 1 by y, integrative factor is 1 by x is equal to integral right hand side function q of x minus x times of the sine x into integrative factor is 1 by x into dx plus c. Yeah, this x is a cancel. Then that implies 1 divided by xy is equal to integration of the sine x into dx plus c. We know integration of sine x is a minus cos x, so that 1 divided by xy is equal to minus cos x plus some constant c. Then this minus cos x we can write on the left hand side, then we can get 1 by xy plus cos x is equal to c. It is required general solution to the given differential equation. Let's go to the next example. Solve xy into 1 plus xy square into dy by dx is equal to 1. Now we have to write this equation as, by cross multiplication, dx by dy is equal to xy times of 1 plus x y square. Then that implies dx by dy is equal to xy plus xy into xy square, x square y cube. Then that implies dx divided by dy minus xy is equal to x square into y cube. So that we can say it is a linear differential equation in x. Here x power 1 and its derivative power 1, so that we can say it is a linear differential equation in x if it does not contain the x square on the right hand side. So that we can say it is a Bernoulli's differential equation in x. We can convert this differential equation to the linear differential equation by dividing the x square on both sides. In the previous example, right hand side we have the y square. Actually it will become the linear differential equation in y. It does not contain the y square. Coming to here, x power 1, its derivative power 1, it does not contain x square on the right hand side, then it will become a linear differential equation in x. That's why we are saying it is a Bernoulli's differential equation in x. We are going to convert this differential equation to the linear differential equation by dividing the x square on both sides. Divide x square on both sides to this differential equation 1. We get 1 divided by x square into dx by dy minus y into x divided by x square is 1 by x is equal to y cube. Right hand side x square by x square, that will be cancelled. Now we are giving the equation number 2 to this. Now we have to substitute 1 by x is equal to u. Then we can get this derivative 1 by x square into dx by dy is equal to some quantity. So that we have to substitute u is equal to 1 by x. Here the independent variable is y, that means here we have the derivative with respect to y, so that we have to divide the we have to write the derivative on both sides with respect to y. Then du by dy is equal derivative of 1 by x is minus 1 by x square into dx divided by dy. Then that implies 1 by x square into dx by dy is equal to minus du by dy. Now we have to substitute these both quantities in the above equation, that is equation number 2. Then we get 1 by x square into dx by dy is minus du by dy minus y into 1 by x is a u is equals to y cube. Coming to the linear differential equations, the derivative coefficient is always unity plus 1. Here we have the negative minus, so that we have to convert this one as a positive by multiplying the negative on both sides. Then we can get du by dy plus y into u is equal to minus y cube. Now I am giving the equation number 3 to this. Here u power 1 and its derivative power is a 1, so that we can say it is a linear differential equation in u. So that here p of y is y and q of y is minus y cube. Now we have to find its integrative factor. It is a linear differential equation in u with respect to y, so that we have to write the p of y, that is a y, and q of y is a minus y cube. Coming to its integrative factor, if is equal to e to the power integral p of y into dy. Now we have to use this formula to find the integrative factor to this differential equation. The integrative factor if is equal to e to the power integral p of y into dy. Then this is equal to e to the power integral p of y. What is the p of y here? Y. So that y into dy. Integration of y is a y square by 2, e to the power y square by 2. This is a required integrative factor. Now we have to write its general solution. Here the dependent variable is a u, so that the general solution of the linear differential equation 3 is u into integrative factor is equal to integral the right hand side of the function q of y into integrative factor into d y plus c. Then we know what is the u here. U is 1 by x, q of y is minus y cube, and the integrative factor is e to the power y square divided by 2. We have to substitute those three quantities in this expression. U is 1 by x, integrative factor is e to the power y square divided by 2 is equal to integral the right hand side of the function is minus y cube minus y cube into integrative factor is e to the power y square divided by 2 into dy plus c. Just we have substituted these three quantities. These three quantities: u, its integrative factor, q of y. Now we have to evaluate this integral, then we can get the required solution to the given differential equation. Directly we cannot evaluate this integral. We can evaluate this integral by substitution, so that we have to substitute y square by 2 is equal to t. Then the derivative of y square is 2y divided by 2 as it is into dy is equals to dt. 2 cancel, then we can get y into dy is equals to dt. Now we have to substitute these expressions in this integral, then we can get 1 by x into e to the power y square divided by 2. Right hand side quantity we are writing as it is here is equal to minus, here y cube is, we can write the y square into y is a y cube, e to the power y square divided by 2 into here dy plus c. Just I wrote the y cube as here just y square into here y square into y as here same as y cube. Now we are going to substitute the y into dy, replace the dt. Minus y square replace, we can write the 2 into t, e to the power y square by 2 is equals to t, y into dy is dt plus c. Then that implies 1 by x into e to the power y square divided by 2 is equal to minus 2 times of the integral t into e to the power t into dt plus c. We can evaluate this integral according to the integral by parts integration of uv formula. We know the integration of uv is u into integral v dx minus integral u dash into integral v dx whole into dx plus c. Now we have to use this formula to evaluate the above integral t into e to the power t e to the power t into dt. When we are evaluating the integration of uv, first we have to arrange the uv in the form of the islet. I means inverse function, L means logarithmic, A means algebraic, T means trigonometric, E means exponential. This is the algebraic, T is the algebraic, that's why we are writing this as U. E power T is the exponential function, that's why we are writing this as a second function V. Now we have to evaluate this integral according to this formula. 1 by x into e to the power y square divided by 2 is equal to minus 2 times of the, first we have to write the u as it is, t. Integration of e power t is, we can write the same as the e power t, we will write that one in the next step, e to the power t into dt minus integral u dash derivative of t is 1. Integration of v is e to the power t, integration is same as e to the power t into d t plus c. Then that implies 1 by x into e to the power y square divided by 2 is equal to minus 2 times of the here. integration of e power t is same as e power t into e to the power t minus integration of e power t is same as e to the power t plus some constancy. Then that implies 1 by x into e to the power y square divided by 2 is equal to, here e power t is a common, so that minus 2 times of t minus 1 into e to the power t plus some constant c. Then that implies 1 by x into e to the power y square divided by 2 is equal to minus 2 into t is y square divided by 2 minus 1 into e to the power t, t is y square divided by 2 plus some constant c. It is a required general solution to the given problem. I gave 3 worksheet problems. You have to practice them. Then you can able to answers to the another questions in the examinations. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.